Hello there, great turns. Welcome to the first lesson of Euclidean geometry. I hope that you guys are good, and I know you've recently just opened and now here comes Euclidean geometry. And I know that some of you guys, Euclidean geometry is truly a nightmare, but make sure that you stick with me in this series of lessons, and by the time you're done with these lessons, I assure you Euclidean geometry will be one of your favorite topics, right? So this is an advantage because also grade 11s and grade 12s can come in for this one and also do some sort of revision. So this, what we're doing here, was actually done from your grade 8, 9, and we are still doing it in grade 10. So if you think there is a shortcut, there is no way you're gonna be good in Euclidean geometry without doing this revision. So please make sure that you save yourself from too much work deep in the term. Now you want to go back, please make sure you start here, right? So today we'll be doing the revision of lines, angles, triangles, and polygons. But I'm going to cut these lessons into 2 or 3 such that it doesn't become very long, right? Because I know that for you guys it now gets too overwhelming when the videos are too long, right? Let me get into business. So the first thing that we'll be doing today is revision of lines, right? So on the first one, we are dealing with angles on a straight line, right? Or we're dealing with what happens when we have a straight line, right? So the first thing that we must know on a straight line is that the adjacent angles on a straight line, which means adjacent simply means next to each other, right? Okay, so it means that in this case, since we have B, it will mean that for B1 plus B2, that would be equals to 180 degrees, right? So it means that every time when you are dealing with a straight line and it happens that there are adjacent angles next to each other, it means that these adjacent angles are supplementary. Supplementary means adding up to 180 degrees, right? I hope that you guys are getting the hang of this and you're still not confused, right? So it's just as simple as that. There's no trick to it. It's straightforward. So B1 plus B2 is equals to 180 degrees, right? Angles on a straight line, that will be the reason that you use, right? Secondly, on number 2, we have angles around a point, right? So what do we know about angles around a point? So you can see this angle here, 1, 2, 3, 4. Angles around a point all add up to 360 degrees. So now it will mean B1 plus B2 plus B3 plus B4. What is this equals to? This is equals to 360 degrees. And when you find a question like this, your reason will now be angles around a point, right? Or reflex angles, right? So we're still doing revision here of lines, right? So what are we doing on the third situation here, right? So here we're trying to see that what happens if we have two lines, which is AB and CD, that are cutting each other or are intersecting with each other, right? So the minute we have two lines intersecting with each other, we are introduced to this new type of angles called vertically opposite angles. So these angles that are facing each other here now, that would mean that E1 would be equals to E4. And what would be the reason? That is vertically opposite angles or vertical opposite angles, right? Okay, so now that only does not just apply to E1 and E4, but it also as well applies to E2 plus E3. They are also vertically opposite. Right, so this is still the simple stuff, and remember we're just doing revision, so it's just quick passing on these things here, right? So going on to the next thing that we find, we have now angles when we have parallel lines. Right, so I forgot to add the parallel lines here. So if we have parallel lines, right, so now these lines are parallel lines. So the minute we have two lines that are parallel and a line that is cutting in between the two lines, right, we are going to establish three types of angles, right? So the first type of angles, so we have already dealt with the vertically opposite angles, right? So don't you ever find yourself in one situation or in any situation saying that we only find vertically opposite angles when we have parallel lines, right? So vertical opposite angles just only need to have intersecting lines, right? There's no parallel lines needed there. If you had that confusion, then from today you know that for vertically opposite angles, there's no need for you to have parallel lines, right? Now we come to these three types of angles that require us to have parallel lines. What will be the first one? The first one, we have what we call corresponding angles. Corresponding angles. Right. So how do we see corresponding angles? So corresponding angles, let me make an example. That would be angle 1 here and angle 5. Right. So in other words, it means that angle 1 will be equals to angle 5. And what will be the reason? Corresponding angles. Right? Now, do you end there? No. Remember we said the requirement for us to have a corresponding angles must be that parallel lines. So you must now state the parallel lines. It means that it is because AB is parallel to CD. Now, if you don't write these parallel lines, the examiner has a full right to give you wrong. Right? So please note that. Right, where are the other set of parallel lines or corresponding angles that we can get? 2 and 6. Right, so you can see that if we look on top of each of these lines, we see that on the right hand side we have 2 and 6. So that's another way in which you can look at that. Or others tend to say that this thing forms an F shape. So if we can see here, if we were to form an F shape, here, the angles there, not sure if that is clearly, it's clearly visible. So you can see that here as well, we're forming an F shape, right? So if we can have an F here, if I can just draw a line here and this sort of becomes an F, right? So that's how you see corresponding angles. So we are saying that another angle that we can have, it's angle 2 is also equals to angle 6, right? So you say the same thing, corresponding angles, AB parallel to CD. Where are the other set of corresponding angles? We can see that we have 3 and 7. So we can have angle 3 is equals to angle 7, corresponding lines, AB parallel to CD, right? What is the last one that we have? Angle 4 and angle 8, right? So angle 4 is equals to angle 8. Why? Corresponding angles, AP parallel to CD. Same reason. It doesn't change, right? So I hope that you guys are still with me and are not confused yet, right? What is the second type of angles that we can find when lines are parallel? We have alternating angles. Right, a lot of people love these ones. Alternate angles. So these ones form a Z shape. So we can have one there and another one there. Right. I know that is not visible enough, but you'll be able to see it on this diagram here. Right. So now we are coming with alternate angles. So let me use a purple color for that. So how would you see alternate angles? So alternate angles would be, if we were to focus on 3 here, so that would be 3, you throw a Z shape, and what? 6. Right. So in other words, it means that angle 3 is equals to angle 6. Why? These are alternate angles, right? Are you done there? No. Remember, we said before we can have alternating angles, we need to have what? Parallel lines. So parallel lines are a requirement for this type of angles. So it means that we must go on to say, because AB is parallel to CD, right? The minute you take this out, this thing is incorrect here, right? Okay, let us go on to check which other alternate angles do we have, right? So if I can focus on 4 here, 4 forming a Z shape and 5, right? So you can see that angle 4 is equals to angle 5. Why? Alternating angles, AB parallel to CD, right? Just that. Nothing more, nothing less, right? So others tend to say, now, because the Z shape is in, we normally write Z like this. So it doesn't mean that this one here now won't be a Z shape, right? Please don't get confused by this. Make sure that you are following through and you are able to identify this in questions, right? Okay. So I'm hoping that I'll be able to do more questions with you guys so that you get to understand how does this work. Now, going on to the last type of angles that we usually get when we have parallel lines. Now, those would be co-interior angles. Right. So co-interior angles usually form the C shape. So this here, right? Okay, so now that would mean that, okay, for co-interior angles, it means now we are summing up. Now we are not saying angle this is equal to angle that, right? So now it's sort of a summing up type of situation, right? Okay, so it means that in this instance, we can have angle 4 plus angle 6 giving us 180 degrees. Why? These are co-interior angles, right? Are we done here? No, we need to go on and say AB is parallel to CD, because for us to have co-interior angles, the first requirement must that we must have parallel lines, right? So please guys, don't leave out this reason here, right? I hope that this guys is making very clear sense to you, right? So what would be the other co-interior angle? Yes, so that would be 3 plus 5, that will give us 180 degrees. And what is the reason? These are co-interior angles. And how did we know that? Because AB is parallel to CD. As simple as that, right? So these are the only 3 type of angles that we find when we are dealing with lines that are parallel. So guys, please make sure that if you didn't get anything, pause the video, go back to the segment that you were left on. Then what would be left on now would be you to do more questions and practice more questions, right? I hope that this guys was very useful to you and that you continue sharing it with other people as well. As I said, grade 10, 11, 12, you all are required to do this revision, right? It's very, very important to you, right? Okay, so you guys join me for the second lesson when I continue with triangles and polygons. Have a great day ahead of you guys. Bye.